Fire gear is heavy, so is water. When firefighters have to lug a fully charged hose up multiple flights of stairs, the physical toll is immediate and brutal. Water weighs over 8 pounds per gallon. The higher you try to push it up a vertical pipe, the harder gravity fights back, stripping away the exact pressure crews need to knock down a fire. A standard fire engine parked on the street can only generate so much mechanical force. Long before the water reaches the upper floors of a modern skyscraper, that street-level pumping capacity maxes out. Curious, analytical tone. This creates a difficult geometric problem for urban planners. If you build a residential tower that stretches high into the clouds, how do you put out a fire on the 50th floor when your equipment can't push water past the 15th? The solution is found in the building's anatomy. Modern high-rises are built at pre-laid vertical water highways called rising mains, which eliminate the need for crews to drag miles of hose up hundreds of stairs. For buildings between 10 and 60 meters tall, fire codes mandate a dry riser. This is an empty vertical pipe running the height of the building, sitting dormant until an emergency strikes. The system begins at street level with a connection point called a breeching inlet. By law, this inlet must be clearly visible and located within exactly 18 meters of a fire engine access road. When a crew arrives, they hook their engine directly into that breeching inlet on the sidewalk, using the truck's mechanics to blast pressurized water straight up into the empty vertical pipe. Meanwhile, the attack crew rides a dedicated fire lift directly to the active floor. They step into a protected smoke stop lobby, finding a pre-installed outlet called a landing valve. This diagram shows the logic of the building code in action. Firefighters simply attach a short hose to that landing valve. Because the code dictates that no point on the floor can be further than 38 meters from the valve, they are guaranteed to reach any room without running out of slack. This logic applies in both directions. Deep subterranean basements must also install dry risers, sparing crews the task of hauling heavy hoses down tight, complex stairwells. The dry riser shifts the burden of water transport away from human muscle and onto the building structure. It turns a chaotic marathon into a quick plug-and-play operation. But street pumps have a hard physical ceiling. Right around 60 meters in the air, the dry riser strategy fails. To push water higher than 60 meters, a fire engine would generate such extreme pressure that standard ground hoses would burst under the mechanical strain. To cross that threshold safely, the architecture must evolve. Buildings exceeding 60 meters require a wet riser, a pipe network that is permanently fully charged with pressurized water. This requires massive infrastructure. High-rises mount heavy water storage tanks on their roofs, supported by internal mechanical pumps designed to independently deliver 27 liters of water per second out of any open valve. Maintaining a continuous vertical water column compounds static pressure at the lowest valves due to the liquid's weight above. Engineers install intermediate brake tanks to interrupt the drop, resetting pressure to a safe 8 bar, ensuring the hose doesn't rip from a firefighter's grip. Once a structure surpasses 60 meters, it can no longer rely on street-level engines. It operates as its own self-sufficient water tower. We often view a skyscraper as a static stack of concrete and glass. In reality, these buildings operate as integrated survival machines. Strict building codes dictate these rising mains are installed progressively, keeping pace with construction crews as the steel skeleton climbs higher into the sky. This requirement ensures that fire defenses are active and pressurized long before the roof is ever finished. A building's height can never outpace its own ability to survive. These brass inlets on the sidewalk are the access points for a vital water artery. They are engineered to neutralize gravity and ensure that even the highest floors are within reach of fire defenses, making it possible to safely reside in the sky.